Hello and welcome to the second episode in our series to program a ChessAI. Now we will continue to implement some basic movement in the chessboard class. So we will maybe do this directly after the constructor. We will start with a basic move method, which just takes in a from cell in algebraic notation and a to cell. And first of all, we will pass the cell values to indices. So we will say from index is equal to pass pass out not to index of we have to say self dot here. So we will use this function in which we will pass in the from cell, and we can just copy paste this line. So we will say 2 and again 2, and now we have our index values. And now it would of course be important to check whether these are even in bounds. So we will first say create a new method, and we will call it def is in bounds, and we will take in a cell, and we will just say we can again convert this to an index. So we just say that our index is the passed cell, and now we say if index bigger or equal to 0 and smaller equal to 63, and return true, else return false. This makes it just a lot more easy for later. So now we say if is in bounds. Maybe we actually will make this is in bounds work with an, no, we'll leave it. We'll just say if is in bounds from cell, and again don't forget to call this from self dot is in bounds to cell. Then we will continue here. So in this case we will now just say that the board at the from index will be saved in a TMP variable. Then we will say that the board at the from index, or the to index, will be replaced by the value at the from index. And then lastly we can say that the board at the from index equal to 0, so an empty board. And for this it might be more handy to have a constant which we will call empty, and we'll set it to 0. And now we will have to import it in here, so we'll just say from chessboard import empty. So we had to move this constant above the class definition, and then we can import it in here. And if we ever decide to change the value for empty, then we can just change it here once, and it will be used in all places where we use empty. And this will now do it. We can actually remove this because we don't need to store it. And our move will be complete. So we can maybe say print successfully moved from cell to cell. And in this case, we will return true. If they are not in bounds, then we will say return false. And maybe before that, we can say print the one of the cells is not in bounds. So a little error message there. And yeah, so now we can already use this. So what if, for example, now we say self.board at 0, so at A1 is equal to 1. Now if we go into our main in here and we will print it, then you will see that there's 1, 1 at the A1 position. And if we now, for example, say my chessboard dot move, and we will say from A1 to, for example, H8, and then we will print it again. Then now you can see that first we have it here in the bottom left corner, and then it moves up to the top right corner. And this will be very useful for now to implement straight, diagonal, and jump movement as the knight does. We will maybe begin by implementing a few constants again. So this would be maybe a constant of the pieces, so piece constants. And then we will also have directions. And we will say that top is 0, right is 1, left is 2, and bottom is 3. And I will quickly import those as well. Okay, so now, here we go. So first we'll implement the straight line movement, and this will take in a from cell, an amount of steps, as well as a direction. And the directions I've implemented here at the top. And so now we're first gonna pass the from cell to an index. So from index is equal to self.pass algebraic notation to the index, and we'll pass in the from cell. Okay, and now we will just make a quick if statement. So if direction equals top, else if direction equals bottom, else if direction equals right, else if direction equals left. Okay, and the formulas for the index where we would then come out of, for the top, it would be that the to index is equal to the from index plus 8 times the amount of steps. So this just means, if you picture our board here, if we are, for example, at A1 and we want to go 2 to the top, so to A3, then in our representation we have it all in one line. So +8 just means one row above. And so the amount of steps is the amount of times we need to add 8 to get to the rows above. And then for the bottom, it's the same, just that we subtract. And if we want to go to the right, then we just say that the to index is equal to the from index plus the amount of steps, because in this case we're only going the amount of steps to the right. And then again, the left is exactly the opposite. So we will say minus the amount of steps. Okay. And now we can just say if move, because remember, self.move, because remember the move method returns true if it works. And so if move from cell as well as self.pass the index to algebraic notation of to index. So if this returns true, then we will also return, actually it would be easier if we would just return this. So this will return true if it worked and false if it didn't. And now we can move on to our maybe diagonal movement. So our method diagonal move. This will take in again the from cell, as well as an amount of steps. And this time we will need first a vertical direction and then a horizontal direction. And so first we can copy this. We will just pass it to an index again, and then we will maybe start again an if statement. So if the vertical direction is equal to top, else if the vertical direction is equal to bottom. And now in there, in each of those, we will say if the horizontal direction is equal to left, else if the horizontal direction is equal to right. And we can just copy these over here. So in this case, we would be going to the top left. And if we would go to the top left, then the formula for the to index. So if you imagine it again on the board, so we now want to, for example, go down to the go up to the top right, so from A1 in the direction of H8, then in this case we would have to go up the amount of rows that we want to take steps. So if we want to take three steps, then we need to go 3 rows up and 3 to the right. So therefore the to index is equal to the from index plus 8 times the amount of steps and then plus the steps. And this will now be similar. Well, I will exchange these here. So right and left. So now we want to go to the, this should say top right. Now we want to go to the top left. In this case, we still go up the amount of rows. So this corresponds to the rows. But then to the left, we need to subtract. And we can just copy this whole thing to over here. where we would now say bottom as well as here. And now we just, again, subtract. And like above, we have to, oh no, we already did that. So right, right, left, left. Yes, it's working out. And then again, we return this to check if it actually works. And lastly, we would now implement the knight move, which is this sort of jump. So for this, we will just pass in a from cell as well as two directions. So we will call them direction 1 and direction 2. And this is because in this image you can see it pretty well. You have 8 possible moves that the knight can make, and it could, for example, first go to the top, then to the right, or first to the right and to the top, and those will be 2 different positions. So we have 8 possible combinations of the 2 directions. And so we can maybe copy first our if statement from here. So this would be all of the possible values for the first direction, and then we can copy each of these into the case itself. So now we have to be a little bit careful, and then it will be the direction 2. But of course, we won't have the same direction twice. That's how it works, but we'll copy it like this for a moment. So we can then remove them one by one. So here we remove the top, then in the bottom we remove the bottom, and so on. And now we have a lot of different cases. Actually, of course, we can also remove these. Excuse me. So if we move to the left, then we cannot move to the right anymore. So we only take one vertical and one horizontal direction, but they can appear in different orders. So the direction top right over here, and in this case we would have 2. We also should copy the from index, and then the to index would be, in this case, the from index plus, so we're going up 2 rows, so 2 times 8, and then plus 1, meaning 1 step to the right. And now we can continue this for the left. This would work the same way, just -1 in this case. So top left looks like this, and I will quickly implement the rest of them. The main, and this time we will maybe start with a diagonal move from A1 to H8, and we want to get out at H8, and for that to work we would give in first amount of steps, so we have 7 steps, and then we would want to go to the top and to the right. And now if we execute this, then you can see that we start out at the bottom left and we come out at the top right. And now, for example, if we would want to do a straight line movement, so we would again say from A1, we would maybe go 3 steps to the right. And now if we execute this, then we start out bottom left, go 3 steps to the right, and come out here. And we could also say the same thing for the top. So we start out here, and then we move 3 steps to the top to be here. And then lastly, we could also try out the knight movement. So we would again start at A1 and go maybe to the top right. And if we run this, then this didn't actually work yet because there was one thing missing from our knight movement, and that's this return statement. So if we add that and now we execute our code, then we can see that we went 2 steps to the top and 1 to the right. And if we now, for example, change the order of these, so we go first to the right and then to the top, then we will go 2 steps to the right and 1 to the top. And therefore now all of our basic movement capabilities should be implemented. And you will hear back from me in the next episode. Thank you for watching.